All right, let's just dive right in. Time. It feels like the one thing we can all count on, right? It just ticks away second by second. But what if I told you that our entire common sense understanding of time is basically a deception? The more we dig into it, the more it seems like the reality of time is far stranger than any of us could imagine.
You know, the philosopher St. Augustine nailed this problem almost 1600 years ago. It's such a perfect way to put it. As long as nobody asks, we feel like we've got a handle on it. But the moment you try to actually define it, to explain it, poof, it just vanishes.
The image we all have in our heads, the one from poetry and songs, is that time is like a river. It's just flowing, always in one direction, carrying us along for the ride. It's a powerful, intuitive idea. But here's the kicker. What if that feeling, that unstoppable flow, is just plain wrong? So for the longest time, science didn't really mess with that river idea too much. And then along comes Isaac Newton. He didn't just agree with it. He basically put it in a box, gave it a set of rules, and created this idea of a single universal clock for the entire cosmos. You can really see how our thinking evolved. First, we had this idea of time as a giant repeating cycle, like the turning of the seasons. Then, that shifted to a straight line, a story with a beginning, middle, and end. And finally, Newton comes in and just locks it all down. He says there's one cosmic clock, ticking at the exact same pace for everyone, everywhere, no exceptions. And honestly, it's a nice thought, isn't it? It's simple, clean, everyone's on the same clock, a perfect, steady stage for all the action in the universe. But, as you've probably guessed, that simple, clean picture was about to get blown to bits. Enter Albert Einstein. At the dawn of the 20th century, this young patent clerk looked at Newton's perfect, universal clock, and he didn't just poke a hole in the theory. He took a sledgehammer to it. He completely shattered our idea of time, and in the process, rewrote the fundamental rules of reality. Okay, so to get our heads around what Einstein did, you have to entertain a pretty wild idea. Just think about this for a second. What if you, me, this planet, everything in the universe, is always moving at the exact same speed? The speed of light. All right, let's walk through this analogy because it is absolutely key. Imagine a plane in the sky. It has one speed and one speed only, full throttle all the time. Now, we're not watching the plane. We're on the ground watching its shadow. Depending on how the plane is flying, up, down, sideways, that shadow speed can change. It can go fast, slow down, even stop completely. Einstein's incredible insight was this. We are the shadow people, living in our 3 dimensions, and what we perceive is just a projection of a deeper 4-dimensional reality. So here's the big reveal, the core idea. Our universe isn't just 3-dimensional space. It's a 4-dimensional fabric called space-time, and everything, literally everything, is traveling through that space-time fabric at one constant speed, the speed of light. What we call speed in our daily lives is just the shadow moving on the ground. Think about yourself right now, maybe sitting in a chair. You feel like you're perfectly still, right? Not moving through space. Well, according to Einstein, that means all of your cosmic speed, 100% of it, is being spent traveling through the dimension of time. You're aging at the fastest rate possible. But the moment you get up and start walking, you have to borrow some of that motion from the time direction to use for the space direction. This is it. This is why time literally slows down for objects that are moving. It's not some weird sci-fi magic. It's just the basic geometry of space-time. You're trading speed through time for speed through space. So this really is the heart of relativity. There is no universal clock. Time isn't some separate thing ticking in the background. It's a dimension, just like length, width, and height. And it's woven together with them to create this single fabric of space-time. Okay, so Einstein completely changed the game. Time is relative, it's flexible, got it. But there's a huge piece of the puzzle still missing. His equations are brilliant, but they don't explain something super basic, something we experience every single second. Why does time only seem to go one way? Yeah, why does an egg scramble but never ever unscramble itself?
Why can we remember what we had for breakfast yesterday, but we have no idea what we'll have for breakfast tomorrow? It seems so obvious, but in the world of physics, that is a huge, profound question.
Well, the best answer we have for this comes from a totally different corner of physics: thermodynamics. And it all boils down to one crucial concept: entropy. It's basically a scientific measure of messiness or disorder.
Let's use a classic example here. You take a perfectly clear glass of water and you put one single little drop of blue dye into it. What happens? Well, it spreads out, of course. It mixes and mingles until the whole glass is a faint blue. It will never, ever spontaneously gather itself back into that one perfect tiny drop. And the reason is just simple probability. There are just a bajillion more ways for those dye molecules to be scattered and mixed up than for them to be in one neat, ordered spot. And that right there, that is the arrow of time. The entire universe is just like that glass of water. It started off in this incredibly neat and tidy, low entropy state right after the Big Bang. And ever since then, it's just been getting messier and more disordered. This relentless, unstoppable march towards messiness, that is what we experience as the forward flow of time.
And this is where it gets really wild. This physical law is directly tied to how our brains even work. Think about it. Making a memory is the act of creating an ordered record of something. You can only make a record of a past state that was more orderly, that had less entropy than the present. We remember the past because it's the only direction entropy allows our brains to operate.
So it all seems to fit together, right? Time is relative, and its arrow is just a consequence of entropy. Case closed. Well, not so fast, because when we zoom in, way, way down to the quantum level, the whole beautiful picture just falls apart. And this is maybe the most profound puzzle in all of science. When you look at the fundamental laws that govern individual particles, the direction of time just doesn't matter. The equations work perfectly fine forwards or backwards. For a single particle, time isn't really a thing. The arrow completely vanishes. So we're left with this massive contradiction. In our big, everyday world, the arrow of time is undeniable. A glass breaks, it doesn't unbreak. But down at the microscopic level, the fundamental rules say forwards and backwards are on equal footing. So where does our arrow come from? The best guess is that it's an emergent property. It's not fundamental, it just sort of appears when you get enough particles together. Like how wetness isn't a property of one H2O molecule, but it is for a whole puddle.
So look at this journey we've been on. We started with time as a river, then it became a clock, then a dimension, then just a measure of growing messiness. And now, when we look at the very bedrock of reality, it seems to disappear entirely. This forces us to consider one final, really radical idea about what reality is. It's a concept called the block universe. The idea is that all of space-time, the past, the present, and the future, already exists. It's all out there, static and whole, like a loaf of bread. And we, trapped by the relentless march of entropy, are just traveling through this block, experiencing it one slice at a time. So that leaves us with this final, truly mind-bending question. Is our most profound experience, that deep feeling of time flowing forward like a river, nothing more than a stubborn but beautiful human illusion?